of gasoline there and started burning it, and it was burned. It was very hot over there, so it burned over there. Here you see the signs that this was arson. The fact is that this is not so clear because sometimes fire does burn irregularly. You have a fire starting by itself, and some parts of the floor, let's say, will have concentrated ash and areas and concentrated burning. It can happen naturally. It's not so clear. So again, a professional would say, well, I know exactly what kind of shape that was. That must have been couldn't have been natural. It had to be from a puddle of accelerant. Okay, but again, it's not so clear that just because it's puddle shaped that it is a sign of arson. It's a good point. It's a good thing to know, but it's not always that clear. In a court, they can contest this. We can look for burn marks that go through cracks in the floor. Now, that is hard to contest. If, let's say, there's a crack leading from here down to, let's say, to the floor below it, well, if it's an ordinary fire, it wouldn't go down. But if it was an accelerant, being a liquid, it slips into the crack in the floor, naturally will burn through the crack in the floor. So if we see the burning going through that crack, then it's a sign there was an accelerant. Also, sometimes even if it's hot enough, wood does not necessarily burn that hot, but a lot of these accelerants are designed to burn hotter than wood. So if you see them burning hot so that even concrete can flake off, that's a sign that that an accelerant was used, right? Especially near the concrete, which made it, which even was able to burn the concrete or to affect the concrete. But again, this is also contested in a court because sometimes natural fires can actually do these things. Here's another thing you might see in the picture. This is not a V shape. The V goes out like that. This is not a V shape. The idea is this was an accelerant, and it burned so hot it actually burned away some of the things that would have produced this burn pattern. So that's, again, if it burned hotter than an ordinary V-shaped flame, then it's a sign that it's not an ordinary flame, and there was an accelerant used. Another way to test for accelerants is using what they call a sniffer device. It takes in the air, and if there's hydrocarbons in the air, usually from accelerants like gasoline, lighter fluid, other diesel fluid, whatever it might be, air is taken in, it's passed over something that heats it. Now, if there are hydrocarbons in the air that it took in, then these hydrocarbons will burn, they will react, and the temperature will rise, and this thing tests for that temperature rise. It's very sensitive, but only for accelerants that are liquids that evaporate. If people use paper accelerants, a bunch of paper on the floor, it's useless for that. Now, this is not conclusive, but it is, again, a sign that there was arson there. It's it leads us into a certain direction to suspect that and to start doing other investigations for it. The other thing that's used to detect accelerants are arson dogs, like this one. You might notice these cute little booties. Remember, these canines, they walk over places that have been ravaged by fire and can be very hot, so they need them. His name is Sherlock. Okay, so you're at the scene. We want to bring stuff to the lab. How do you collect the evidence? It's really, we don't do much in the case of arson except try to detect accelerants. There's not, and also what was used to start the fire, a lighter or a candle or whatever else. So what we do is we take about 2 to 3 quarts of ash or debris from the place where the fire started, especially places that are porous, like rugs, wood, or cloth, because if there was an accelerant, it'll get absorbed into the rugs and the cloth, and even the wood. So we want to look. We're looking for accelerants. We're going to look for these places. We also need substrate controls, like places that are not where the fire was not started, either burned places or not burned places, and we should not be finding an accelerant over there because accelerant isn't put in places where the fire is not meant to be. So if we find some hydrocarbons there, or maybe it really wasn't an arson. Maybe the person stored gasoline in their house. So we have to search not only the place where we're pretty sure that there was an accelerant, but even places nearby to show that no, there was no accelerant anywhere else, and therefore someone put accelerant there. So or we might find some let's say, some other hydrocarbon source. Let's say the person might have been, they might have had some printer toner, like on his kitchen table where the fire wasn't, or where the fire didn't start. So we take samples near where the fire started, and we take it near the kitchen table. If we find a hydrocarbon source or accelerant or a hydrocarbon source near the kitchen table, we have to know what it is. So we can say, oh yeah, that wasn't really, that doesn't prove that it wasn't arson, that it was just, oh, the guy stored toner all over the place, or the guy stored flammables all over the place. He stored toner on the kitchen table. We put it in an analytical chromatogram. We'll deal a little bit with this soon. And we'll say, oh no, the accelerant and the fire source, that was gasoline. What we found on the kitchen table was toner. So we can actually, again, we need the information, and we need from not just the place where the fire started, but also places around it. Again, these are substrate controls. Whenever we can collect evidence, remember the substrate controls. We also look for other things besides accelerants, igniters, a match, a lighter. And it's important to know the existence of something called a Molotov Cocktail. This is very often used to start fires. What they do, people do is they put gasoline. It burns very well. It burns pretty quickly. You put it in a glass bottle. Put a cloth inside it. You shake the bottle, make sure the cloth gets a lot of the gasoline, and you ignite the cloth wick. Now, it'll burn the cloth wick, and you better throw it and run, because the gasoline will not only burst into flames, it'll actually explode. Now, if the gas bottle breaks before that happens, okay, it'll spread the gasoline all over the place and cause the fire. Otherwise, it'll just explode the gas bottle. Again, causing fire to be all over the place. This is a common way of starting a fire, of an arsonist starting a fire. I mean, like throw it through a window and run away. So that's really, it's relatively convenient. So we can, if this happens, we should look for the bottle. If it's a glass bottle, it doesn't necessarily burn in the fire, so we can recover that, and maybe we'll be able to find out, where does this bottle come from, who bought it, and start investigating from that angle. If the wick survives, that's also evidence. Again, maybe we can tell where the wick came from. Maybe it came from a torn cloth, and we can actually match the fibers of that cloth to something on a suspect. If we have a suspect, get the suspect's clothing if possible. It may have traces of the accelerant, right? Gasoline splashes, it might splash onto his coat, and we might actually get information about that. We may be able to prove the suspect actually was involved with accelerant and may very well have been involved with the crime. We also have to preserve the fire evidence. Now, remember, we are looking for accelerants, and which evaporate. So we put our, let's say, a quart or so of ash or fire origin area, debris. We have to use an airtight container because we don't want it to evaporate anymore. So put it in what, it looks like a paint can. Basically, it is a paint can, but there's no paint in it. That it seals. This seals, so any accelerant will stay in there. Now this has to be airtight. We don't want any air to get in. Now, compared to other DNA and biological evidence where we insist that it be that they have some air circulation to avoid, let's say, bacteria or mold growing in there. But for arson evidence, airtight, must be airtight. We also leave space at the top, so if there is any accelerant, it will evaporate and get into 1/3 of the empty space on top. And we want that. We want it to evaporate because